So you always want to begin with what was given. And what is given is this statement. So we start there and we say given. Next, take a look at what these things are in the picture. Angle ABD is a measure. Angle ABD is this rotation from here to here. Here's its interior. What about angle CBE? From the C to the B to the E, that's this rotation, and here's its interior. Alright, so how are we going to prove that angle 1 is equal to angle 3? Well, you want to start with what's given. For this green angle, for example, CBE, notice that it's comprised of two parts. And we learned what's called the angle addition postulate, which says part plus part equals whole. So that will be our next statement. The measure of angle CBE, which is the entire green rotation, that's the whole, and it's equal to its part plus its part. Alright, and we can do the same thing on this side, where the whole rotation, which is angle ABCD's measure of angle ABD, that's equal to the sum of its parts, the measure of angle 1 plus the measure of angle 2. What gives us a right to say this statement? Well, when a whole angle is equal to the sum of its parts, that's the angle addition postulate. In this process, let's remind ourselves, what's our destination? What are we trying to get to? We are trying to show that the measure of angle 1 equals the measure of angle 3. So remind yourself of the destination. Let's take a look at where we're at. Do we see this destination in here somewhere? And we kind of do. It's kind of right here and here. And what do you notice about what we don't want? It's the exact same thing on both sides. So if we could get rid of the measure of angle 2 on both sides, we'd be left with exactly what we're trying to show. So let's do that. This says the green expression plus the measure of angle 2. Let's subtract the measure of angle 2. And when we subtract it from the left, we're left with just the measure of angle 1. And when we subtract the measure of angle 2 from the right, we're left with the measure of angle 3. We use the subtraction property of equality. And we're done, because that's exactly what they asked us to show. Well, I hope that helped. Just trust me on this. If you keep trying these and listening to your teacher and working through these in class and your homework assignment, they will start to make a lot more sense. In fact, it's not unusual for students at the end of the year to say, Mr. Compery, these proofs were really hard for a while, but actually they became my favorite part of the class. You might not believe me, but that's actually true. Many students come to realize that doing these logical reasoning exercises, these proofs, really is the best part of geometry class.